So putting aside this predetermined shape allows us to choose an approach to cavity design which is based on the histopathology of the disease, rather than what we have to do in order to keep the restorative material in place. And what this does is allows us to retain more tooth substance than we would have perhaps in the past. So remember, my view is that restorations are placed primarily to bring the biofilm to the surface, out of the cavities which patients cannot access to remove biofilm effectively, and to seal off the cavity from the substrate, the sugars that are available in the mouth when we eat, so that the lesion cannot progress. They're the key reasons for placing restorations. So you'll see this picture you'll recognise outlines the two zones that we need to consider when designing cavities. So which part of the tooth structure needs to be removed and which part of the tooth structure needs to be retained. So this more superficial or infected or destroyed layer of dentine needs to be removed. So this would be included in our cavity design. We'd also need to then consider that this is potentially unsupported enamel, and we may need to eliminate that. And the same thing here. Okay, so our final cavity design may look something like that. Another example here, you can see that we don't have an open cavity. We have a breakdown or a cavitation of enamel here. But in order to access this necrotic dentine here, we actually need to cut through relatively sound enamel. And to do that, we'd need to use a high-speed air turbine handpiece with an effective cutting burr. And again, once we have thought about this, we need to remove all of this necrotic dentine, which means that this unsupported enamel excuse me, would have to be included in our cavity design. So remember, the enamel prisms are sitting almost perpendicular to the dentinal surface, so this is all supported enamel. This unsupported enamel, which is sitting on necrotic dentine, it's unsupported, it'll collapse, needs to be removed. Here we can see some radiographs which are showing us radiolucent areas which indicate significant loss of minerals and therefore probably significant carious dentine. So here we see a large area which is probably necrotic dentine. Here is the small cavity in the surface of the enamel. But you can see here that in order to remove this lesion, we can't actually come in from the side because the 6-year-old molar is sitting adjacent to it. So what we would need to do is cut through from the occlusal in order to gain access to that lesion. So our cavity design may end up looking something like this. And additionally, we may cut a retentive area into the occlusal, so our final outline in cross-section may look something like this. Here we can see that the occlusal surface indicates that there is probably a cavitated lesion here into dentine, and if we were able to look at the tooth in cross-section, which we are here, but we can't do that clinically, you can see that there is dental involvement and probably cavitation here. But in this part of the tooth is a non-cavitated lesion, and you can see we're not getting significant involvement of the dentine. So in this particular case, we can access from the occlusal, so we'd use our high-speed handpiece to remove enamel, and this is the shape from the occlusal of our cavity. This is actually called the outline form. Okay, this area we would probably leave, we wouldn't cut into that, but we would want to seal that. In cross-section, our cavity from the occlusal, removing the necrotic dentine would probably look something like that. So let's have a look at where these lesions will be and potentially consider how the principles of cavity design may be applied slightly differently according to the surfaces of the teeth that are affected. Now, dental caries can affect, of course, any part of the tooth where plaque is left to accumulate. But most commonly, in human teeth, we will see three areas where we will get cavitation. The pits and fissures of the teeth, and these commonly occur on the occlusal surface, but may also occur on the palatal surfaces of molars. There's a palatal groove commonly behind the front teeth, so the palatal surfaces of incisors, and the buccal surface of lower molars are commonly pitted